Now this, what I'm doing, try to understand this, guys. First, we are calculated the error for an individual values. We got the total error by doing the summation. This total error we usually represent it with the R, that is a residual. Then we were, because of the sign, they are getting cancelled and we are getting 0. So what we did it, we have squared it. This is one of the error detection matrix that is called as R squared. Okay, R squared. Now, there is error detection mechanism. In other words, when I'm saying error detection, error matrix, that is error detection mechanism. Okay, and here I'm getting it after doing the square, I'm getting it 3.6. But I want to distribute this one equally to all the data points. So I divide it by 5 because we have the 5 data points. I got it 0.7, right? This is, we are applying the mean, right? So we call it as a mean squared error. Now, again, the effect of the square root is there. So what I did it, I applied the square root to remove this. So we will call this one as root mean square error. Now this is nothing but, this is represented as R, sorry, RMSE, like this we will represent it. Okay, these are the three. There is one more is there, absolute, we call it as mean absolute error. This is identified as MAE. This is also identified as MAE. What is this one is? See, if you know it or not, I'm not sure about that. So if you want to remove an sign, there is something called as absolute. That is like this, you will be giving it. If I have it -8, after applying the absolute, it will become 8. So it will neutralize the sign. Okay, this is called as absolute. So here what it is saying is, instead of going with the R square, go with the absolute. Then my formula will become, okay, summation of, okay, y minus y hat absolute, not square, absolute divided by n. This is a formula. N is number of values, and this is the absolute one, and we are calculating the mean. Like this we are going to do it. Okay, so these are the 4 error detection mechanisms. Now I wanted to quickly show you here. Okay, linear regression, error, now here you can see it very clearly. So this is okay, that's one. Mean squared error, that is MSE. The root mean squared error, that is RMSE. Absolute mean absolute error, MAE. And the other one is, this you can ignore it. Again, for this we have to go very deeply with our absolute error. That's okay, not a problem. The additional is R squared error, that is R squared. Clear? So you can see that we have all calculated the different error matrix. Okay, so what is this error matrix first of all? So just these are the 4 different error matrix we discussed. How to define this error matrix? Okay. What is error? See, we can write it as error matrix is nothing but a mathematical calculation or mathematical tool used to measure how well our model predictions match the actual value. This is our model. This is our model. So how well our predicted values, okay, how the matches the actual values. That is what it will check it out. Now, how to measure it? So how to define it? Error matrix are mathematical calculations or tools. You can see it used to measure how well a model predictions match the actual values. How well the predicted value, model's predicted value matches, or I can give it as predicted value. Predicted value match the actual value. They quantify the difference between predicted value and actual values. Actual values, sometimes we call it as true values. So don't get confused. Okay, sometimes we also call it as true values. Lot of cases you will see in the definitions, they will use the true values. Okay. Now, this quantify the difference between predicted value, which helps us to understand how accurate model prediction is. Model is predicting, we can see. Okay. Now, there are actually majorly four are there. Okay. Now, they all are different stuff. First one is R squared error. R squared score, you can see it as error. And then there is something called this, you will indicate it as R square. Now there is something called as M mean squared error. Mean squared error, that we will indicate it as MSE. Next one is root mean squared error, that is RMSE, root mean squared error. Then there is something called as mean absolute error. This is nothing but MAE, absolute error. Now we know the different formulas. This is for our regression. Remember this. This is specially for our regression. This is for our regression. Again, there is classification. There is different things are there. Accuracy, precision, recall, F1 score, and confusion matrix. We can deal with them one after the other. This is what is called as now. Okay, yeah. So now you know that how this is calculated. Now, there are different types of linear regressions are there. One is called as okay, 1 second, guys. One is called as simple linear regression. Other one is multilinear regression. Okay. Now, what is the difference between this simple linear regression and multilinear regression? Now, let me explain you. See, different types of regression. Now, before going further with the types of regression, there's types of linear regression. First one, we will call it as simple linear regression. Second one is called as multilinear regression. Multiple linear regression or simple linear, anything you can say. Now, before going to this, there is a very, usually the people get confused a lot. There is something called as loss function and cost function. Cost function. Okay. See, loss and cost is almost same. They are same. Now, when you want to define what is a loss function, it is a mechanism through which we identify the error in one data point. What is the error between the actual value and the predicted value? This is called as your loss function. Okay. How we can define this one? Defining loss function is nothing but it is you can say it as it is a mathematical calculation or mathematical formula that measures error between a predicted output and actual value for a single data point. It will measure the error between actual and predicted value for a single data point, for a one single data point. That is called, please remember this. You know, if the person enters into this, they will definitely ask you, what are the error matrix is there under the regression? See, again, error matrix under regressions are these. The error matrix under the classification is different. Okay, they are not the same. They are slightly different. That is, if you, I just now I told you, accuracy, like confusion matrix, F1 score, all this comes over there. Okay. Now, a loss function is, it is a mathematical formula that measures the error between predicted value and actual value for a single data. Now, that is nothing but you can take the formula like this. Loss function is loss function. Here it is. It will be y minus y hat whole square. Now, loss function, cost function. Now, let's talk about this is a loss function. Now, what is the cost function? Cost function is nothing but it is just like loss function only, but it will calculate the total error. Okay, it will calculate the total error over the entire data set. Okay, or you can say it as total. It measures the average error over the entire data set, and it will combine all the losses in the of the individual numbers, and we will perform overall how much it is an average. Okay, that is what it will be doing. So a cost function is again a mathematical function that measures average error in a data set, entire data set, by considering each and every data points error. By considering each and every data points error. A loss function is a mathematical function that measures average error in an entire data set by considering each and every data point of the data set. Each and every data point error, you can say it as. Okay, in a simple, guys, here this will calculate a single. Now I will show you how the formula look like. Cost function is nothing but summation of, okay, y minus y hat, okay, y minus y hat. Now again, you are keeping the square or not, it's up to you, divided by n. We will do it something. Okay, the cost function. Again, if you want to keep the square, you can keep the square, because however we are going to remove the. Now this we can write it as in a short form, 1 minus n summation of y minus y hat whole square, or absolute, anything you can go with. This is called as cost function. Cost function is nothing but it is going to calculate the total error in the entire data set, and it will calculate the average for that. That is what is called as loss function. Okay. Now Okay, one small thing is there. Tomorrow we can start implementing. Here, this one. That is simple linear regression. What is a simple linear regression is, see, what I said it, linear regression means estimating the relationship between independent and dependent is called as regression analysis. What is linear regression? That is nothing but estimating the relationship between independent and dependent column by drawing a straight line is called as regression, linear regression. Now, what is the simple linear regression means? Estimating the relationship between a single independent column and single dependent column is called as, by drawing a straight line, is called as simple. There will be only single independent column and single dependent column. That is what it is. So, estimating relationship between single independent column with single dependent column by drawing a straight line. Straight line is called as simple linear regression. Now, simple linear regression, the equation is y is equals to mx plus c. Again, remember this, in the future or in your earlier career, whenever you are dealing with any straight line or linear, your equation starts with y is equals to mx plus c. Okay. Now, so here y is equals to, I will give it as y is equals to mx plus c. This is the equation of this. And this we can write it as also y is equals to c plus mx. Can I do that? Yes, you can do that. Y is equals to c plus mx. It's slightly, I'm changing the position. Why I'm doing, I will tell you. Now, what is a multi-linear regression or multiple linear regression also we can call it as? This is estimating relationship between multiple independent columns with single dependent column. Dependent column with the help of or by drawing a straight line. By drawing a straight line. Okay. A multi-linear regression estimating relationship between multiple independent columns with a single dependent column by drawing a straight line is called as. Now again, try to understand this, guys. Okay. Here we are talking about single independent column and single dependent. So our independent columns are indicated with X. Once. Okay. Independent column. Sorry. Y is equals to dependent. Okay. This is an independent column and this is a dependent. Good. Fine. Now, okay. here single independent and single dependent. Can you see it? So our equation is y is equals to mx plus c. Single independent and single dependent. Sorry, single independent and single dependent. We have it. Okay. Now here, when you look at this, multiple independent, that means x will be multiple. So how you'll represent that one? x1, x2, x3, x4, so on, like this, xn. Now single dependent column. So y will be only y. Now the question is, what about the mean? Sorry, slope. If you look at the slope over here, slope equation. Where is the slope equation? Here. Slope is dependent on what? Slope is dependent on the x as well as y. So if there is a change in the x, there is a change in the slope. So here, what will happen is my slope will become m1, m2, m3, and so on till mn, like this. I'll be doing it. So here my equation will become, I'm writing it over here because again I can't write it like here. Y is equals to C I'm keeping the constant like this, and m1 x1 plus m2 x2 so on till mn xn, like this, and x. Okay, this is called as multilinear regression. Okay, so there is again simple linear regression and this is the equations, please remember it. And these are like what are the error matrix is also, this is a very, very important one. This one is really very important. There is a very, very good chance of asking these questions. Okay, now this all I explained you. This is nothing but an explanation for you. So yeah, I will share it. And tomorrow we are going to implement these two. That is simple linear regression. And again, the coding wise, we have done it, guys. We have done it in the feature engineering, complete coding. But here I will show you once again how we can do it step by step process and how we can use this different error detection mechanisms to calculate the error. Okay, chalo, I will stop it over here, and we will meet tomorrow to continue with the things. And I want to let you know this Saturday and Sunday we may not have the class. Again, till Saturday and Sunday, till Friday, we will be having the class. If we have it, I will inform you a bit early. Okay. Thank you very much. Thank you, guys.